Hi, we're going to talk about solving equations symbolically today, but we're going to first start by just kind of tying into what we did on the previous day when we were solving situations with pouches and coins and figuring out how much was in each side. And so the one thing that's really essential to solving equations or solving these bags and coins problems is to maintain equality. So that's what this slide is talking all about, is how important it is to maintain equality as we work through these problems. So what I'm going to have you do is I'd like you to, if you have a composition book, to keep track of these, not those, these next things, these statements. So what I want you to start off with is this equation, 85 equals 70 plus 15, which is true. We're going to do the same equation 4 times. So when I do this and I write it in my composition book, I like to just kind of break my composition book up into 4 parts. And then maybe I would have it written here. And then I would write it again over here and write it again. So I'm going to write it 4 times on the lines. Okay, so let's get started then. So you have it for the first time that was written, probably in the top left-hand corner. And we're going to remember that 85 equals 70 plus 15. That's true. So what happens, though, if we then divide this up into 2 parts so that 85 is on one side and the 70 plus 15 is on the other side? So these are two scale. It's like a scale. It's balanced. So 85 is the same thing as 70 plus 15. They're the same at this point. If I were to subtract 15 from the left-hand side, if I was going to subtract 15 from the left-hand side, here is how I would show that I'm subtracting 15 from the left-hand side. I would write subtract 15 or a negative 15 under the 85, like we do what you normally do with subtraction, like we're working down. And I would write it that way. But if I take away 15 on the left, now it's no longer equal. So for me to stay equal, I have to also take away 15 on the right. I want you to notice where I lined this up. Go back. That this 15 here is lined up under this 15. Why? Because that's the simplest way. 15 minus 15 is 0. So that's probably the easiest place for me to take this 15 away from. So on the left, I have 85 minus 15. The result is 70. On the right, if I have 15 and then I take away 15, that's 0. That's gone. And so I'm only left with 70. So now I have 70 on the left and 70 on the right, and 70 equals 70. Yay. Check. I maintain equality. So let's write this same equation a second time. So when I was saying about dividing it up in boxes, you're going to write this equation again a second time on your paper, like we're starting over. I'm going to draw the line down. I draw the line down the equal sign to show that there's 2 sides. This time, I'm going to add 10 to the right-hand side. I'm going to add 10. I'm going to choose to add 10 to this 15. I could have added it to the 70, but I added to the 15. Doesn't matter. But if I add 10 more to that side, it's not balanced anymore. Now I have to add 10 to the other side so that they'll be equal. So now I'm working down. So to show that I add 10, I write plus 10 under the 85. And now I work down like I would with a normal addition problem. 85 plus 10 equals 95. And then on the right, I didn't do anything to the 70. It's still there in the same place. Nothing changed. But over here on this side, there was an addition problem. 15 plus 10 is 25. Now, is this true? Does 70 plus 25 equal 95? Yes, it checks. So now we've done the same equation twice. Now we're going to do it a third time. So we're going to write the same equation again a third time. So if you're making those boxes, you have one of those third boxes places in your notebook to write this again. And this time I've decided I want to divide the left-hand side of the original equation by 5. So I'm going to divide 85 by 5. Now, if I want to divide by 5 on the left, what would I have to divide by 5 on the right? Now, this is tricky. If I just divide the 15 by 5, 15 divided by 5 is 3. 3 plus 70 would equal 73. Now, I know that 85 divided by 5 is not 73, so that can't be it. 85 divided by 5 is what answer? I'm asking you. Do you know what it is? 17. Now you know. Okay, good. 17. So on the right, I had to divide both 70 and 15 by 5. Because if I didn't, and I only divided 70 by 5, I would have had 14, but 14 plus 15 doesn't equal 17. So I had to divide 70 by 5, which is 14, and 15 by 5, which is 3. And I want you to notice when I showed this division, because I'm dividing everything by 5, I used a division bar under all the numbers to show that I'm dividing all of them by 5. That's a little tricky. We won't do that very often. Well, we will, but it'll be easier. So now we showed division. So we showed how do we maintain equality when we're adding? How do we maintain equality when we're subtracting? How do we maintain equality while we're dividing? Now we're going to maintain equality while we're multiplying. So multiplication is kind of like division. It's going to have to be by everything. So I want to multiply the right-hand side by 4. And I don't want to just multiply 15 by 4. I don't want to just multiply 70 by 4. I want to multiply everything on the right-hand side by 4. So for me to be able to do that, I'm going to wrap parentheses around everything and say times 4. Because what that's saying is I'm multiplying the 70 plus 15, all of that, by 4, not just one of the other numbers. Whatever I do to the right, I have to also do to the left. So I'm also going to multiply 85 by 4 to maintain equality. I use parentheses to show multiplication. Notice this is the one where we do not write anything underneath the numbers. We're actually writing it off to the side of the numbers. All the ones before, adding, we went down. Subtracting, we went down. Dividing, we kind of write it under. But when we get to multiplication, we actually write it beside the numbers. So a little different. Now, on the left, I would have 340. And on the right, I would have 4 times 70 is 280. And 4 times 15 is 60. When you add them together, you get the 340. So those are the 4 things that you need to have in your notes about how to maintain equality and how to demonstrate what you're doing. Because when we solve equations, we're going to be doing these things. And we want to make sure you're using the right method for communication, because that's going to carry you through all of your math classes for the rest of your life. So you want to be doing it the right way. Okay, so now we have, that's actually in your packet on page 5. So now we're at the bottom of page 5, and we're going to talk a little bit about this problem here. So when you solved this one yesterday, most likely most people, what they do is they first combine the bags and coins together, and they say, all right, I noticed that on the left here, I really have 2 bags, even though they're separated by the coins, and I really have 4 coins. So I have 2 bags and 4 coins. Okay, so most people did that first. But another way to look at this is to say that I have 2 sets of the same thing. I have a bag and 2 coins, and I have a bag and 2 coins, and I have 2 sets of those. And you could first solve, you could solve this differently. You could say, well, since I have a bag, I have two sets of a bag and two coins, the first thing I could do is divide this up into two equal parts. And then I can say, well, let me just look at this one here. So now I have a bag and two coins. I could take away two coins from both sides. So I have one bag left over on the left and 4 coins on the right. So there must be 4 coins in each bag. So that's a different way that you could have solved that one. What we're going to be doing today is we are going to be translating these pictures into a more abstract way of writing it. So we're going to change from doing the concrete and we're going to be doing the abstract. So for example here, the bags are X's and the coins are constants. So to represent this, I would say that I have 2 bags or 2 X's, and I have 1, 2, 3, 4 plus 4 coins. On the other side of the equal sign, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 coins. So now I have, that's the way to represent it. Okay, that's probably what you did. But if you thought of it differently and you thought of it as 2 sets, the right's still 12, but on the left, it could have been that you had a set, 2 sets of a bag and 2 coins. And there's 2 of them. So you're multiplying that by 2. Those are equivalent. And 2 or more expressions that have the same value are called equivalent expressions. Equivalent. I'll spell the word equivalent. And then the next word is expressions. Yada, yada, yada. Good. So we should recall the distributive property. Here's how the distributive property works. You do 2 times x and 2 times 2. 2 times x is 2x. 2 times 2 is 4. So that's why they are equivalent. Let me do this next one with you. Okay. And then you can practice on your own. Okay. So yesterday you did this, page 2, number 4. And you wrote out all of your steps. You crossed out 3 coins from each side, and then you divided it up by the number of bags that you had, and then you found there were 9 coins in each bag, and you wrote out all your steps. You're going to be doing that again today, but the difference is, in addition to that, you're going to do something new, and this is where the magic happens. This set of directions that you've given yourself, you're going to follow those directions symbolically and be able to solve these equations symbolically. So that's when it really gets to be special. So this equation that we have here, this picture, can be represented with the equation, and I'll show you the equation, but I'm going to use X to represent the number of coins in each of these pouches because they're the same. So that means I have 3 X's plus, in addition to that, I have 1, 2, 3 coins. And the loose coins are just constants. So the bags are all X's and the loose coins are constants. On the right here, before I cross anything out, I had 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. So I had 30 loose coins. So the equal sign is between them, just like it was before. And now I have the equation 3x plus 3 equals 30, which is demonstrated in the picture. Next, what I'm going to do is just follow the directions I gave myself. So I'm going to draw a line down to help. The first step that I told myself that I did was I subtract 3 coins from both sides. So I'm going to subtract 3 from both sides. Now I'm going to take the 3 away from this 3 and not away from the 3x because I'm going to take coins away from coins. And this 3 represents coins. So 3 minus 3. When I did that, when I crossed out those coins, there weren't any coins left, right? So that means that the coins are gone and all that was left over were the 3 pouches. And when I crossed out these 3 coins over here, there were 27 coins left over. I'm going to read my next set of directions. The next thing I told myself that I did was I divide by 3 on both sides. So I remember how we showed division? I'm going to divide by 3 and I'm going to divide by 3. I'm going to divide both sides by 3. 3 divided by 3 is 1. So that means I have 1 bag left. 1 bag. 27 divided by 3 is 9. So what I end up with is I have 1 bag and 9 on the right, and that is the correct answer. So I've solved it symbolically. And I can check this by going back through and seeing if this works. So 3x plus 30, plus 3 should equal 30. Well, is that true if I use 9 as x? Is 3 times 9 plus 3, does all of that equal 30? Is that true? Well, 3 times 9 is 27, and 27 plus 3 is 30. So yes, it is true. 30 does equal 30. So it checks. I was able to maintain equality. So that's what you're going to be doing today. You're going to be translating. They're going to be going through the pictures and solving them like you did, okay, and writing out your steps to help you so that you can give yourself a set of instructions to follow. But then you're going to be taking it the next step further, be following those directions and actually solving it symbolically. And I mean, this is what I mean by solving it symbolically, where you're using the notation to solve it. Let me just show you number 5. So if I was going to do you already did number 5. You already have all your work for number 5. It's in your packet on page 2. You already know the number of coins in each pouch. When you go to represent this, though, symbolically, for some reason this really tricks people, but let me show you how easy it is. Let me first write down the equal sign. Let me write what's on the left. On the left, I have 1, 2, 3 pouches. Each pouch is x. So that's 3x plus I have 1, 2, 3 coins. On the right, I have 2 x's, 2x, plus I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 12 coins. So that's how you represent it. I don't know why when the pictures, like the bags are on both sides, it really throws everybody for a loop. But that's all you have to do. So now you can try page 6, and the answer key should be in Canvas. Thank you.